Hey, chemistry crew, Mr. Collier here. Today we're going to continue our discussion of gases by talking about the first of our gas law. We're going to talk about Boyle's Law today. We're going to be taking it pretty slow throughout this chapter, going just one gas law at a time, giving you some time to practice, and then coming back. So if you have my packet, again, this is notes page 6, and we're picking up with Boyle's Law. So Boyle's Law, named after a scientist named Boyle, is the law that relates pressure and volume. So what we're going to start looking at with these gas laws is different scientists that realized relationships between certain variables that we talked about in our last video, like, for example, pressure and volume. So this relationship, I think, is pretty straightforward and it's pretty easy to picture. The pressure and the volume of a sample of gas are inversely proportional to each other. Now, a couple things that are key here. One is that the temperature needs to remain constant, and the other is that they are inversely proportional. As one goes up, the other goes down. We're going to see a bunch of different sort of samples of this, and this gives us the equation P1V1 equals P2V2, right? So as one goes up, the other goes down. So if you look at the pressure multiplied by the volume, and if you think about this mathematically, if you make one go up, right, when you multiply two things together to keep them the relationship constant, the other has to go down. So like 3 times 2, and then you make one go up to 3, the other one has to go down to 2. 3 times 2, 2 times 3, they both equal 6. So this inverse relationship also makes sense if you think about just what's going on, right? So here we have a few different syringes filled with gases, and we are changing the amount of pressure acting on them. So here we have a normal 1 atmosphere of pressure, and it looks like we've got about 8 mils of a gas. And if we increase that pressure, right, to 2 atmospheres, we decrease the volume. In other words, gases are squishable, they're compressible. So when you apply additional pressure to a gas, it's going to take up less space. You're going to squeeze on the gas, make less empty space in between the gas particles, and you're going to reduce the volume that the gas takes up. 4 atmospheres gives us 2 milliliters. And check this out, it's all mathematical. So I'm not just saying, oh, it goes down. It goes down at a very nice mathematical relationship. So notice 1 atmosphere times 8 mils. 1 times 8 is 8. 2 goes down to 4. 2 times 4 is 8. When you put 4 atmospheres, it goes down to 2. 4 times 2 is 8. So it's not just, oh, as one goes up, the other goes down. It is a mathematical relationship. As one goes up, the other goes down. And so we can actually calculate that, which, surprise, surprise, what you're going to be doing in your homework after this. So here's another illustration of that. And one more thing, I think I said that temperature had to remain constant. I think I forgot to say the number of gas particles also needs to stay constant. So when we're looking at isolating these little variables, just looking at little pieces at a time, in this case, pressure and volume, that just means the other variables, number of gas particles and temperature, need to be kept constant. So Boyle's law, simply, if you decrease the volume, right, the pressure goes up. Pressure, volume, Boyle's law. Now, you're going to be doing a bunch of problems with this, so I'm going to give you some sample problems here. Here's one. A gas has a volume of 300 milliliters under a pressure of 740 millimeters of mercury. If the temperature remains constant, calculate the volume when under a pressure of 750 millimeters of mercury. So a few things. When we do the problem, you're going to see it's pretty simple, but like I just want to get you used to seeing the different things you're going to be seeing. So in this problem, I see 1 volume and 2 pressures, okay? When you see 2 pressures, that's triggering that you are starting with something and changing the scenario for that particular gas. That's the type of problems we're going to start this chapter with. So here we've got 740 millimeters of mercury to 750 millimercury. The pressure has gone up, right? So I am increasing the pressure. I am expecting the volume to go down, right? I am squishing this more. That's just me thinking ahead conceptually. What am I expecting for my answer? Now let's get into the actual, how do I do this problem? So this is pressures and volumes. This is a Boyle's law problem. Later in the chapter, when you've got a bunch of different laws to worry about, you're going to have to think about, okay, what do I have here? So pressures and volumes, that triggers the Boyle's law. So P1V1 equals P2V2. The ones and the twos can also be thought of as like before and after. So what is my starting pressure? It's 740 millimeters of mercury. What is my starting volume? It's 300 milliliters. What is my final pressure or volume? Well, in this case, I know the final pressure of 750 millimeters. I'm simply going to rearrange this, right? Divide both sides by 750, and my millimeters of mercury cancel out, and I'm left with milliliters. That makes sense. That's the units I'm looking for. So 740 times 300 divided by 750 will give you your second volume, 296. As I mentioned, when I was just thinking about it conceptually, I'm increasing the pressure, so the volume should go down. I'm smushing the gas. It's going to take up less space. Now, the nice thing about these Boyle's Law problems that you do tonight for homework, they can have whatever units they want as long as they're on both sides. So in this case, we've got milliliters, so my answer is in milliliters. They gave me millimeters of mercury. They gave me millimeters of mercury. So those were the same. You might see as you're doing pages 7 and 8 in the packet, you're doing these practice problems with Boyle's Law, you might see some where the units are not the same. Then you just need to do a conversion before you put them into this equation. So say this was millimeters of mercury and this was atmospheres. You would want to convert them both to the same thing before you plug them into this equation. So that's it. You should be able to do Boyle's Law now. Good luck. Let me know if you have any questions.